Right. The next variation is what we call a zero or a zero coupon bond. And it's exactly what it means. It means there are zero coupons. This is a very, very simple structure. It means I pay money up front and I get nothing until the maturity of the bond, in which case I get a big check. It's a present value of a single payment, as opposed to using a formula where there is an annuity portion of the annual or semi-annual payments and an F fee. So here there's simply only a PV and an F fee. That's a zero. These are not nearly as common as a coupon bond. Let's say we have a bond with a face value of 1,000, maturity in 5 years. The market interest rate is 7. What's the cost of the bond? This one is very easy. I hope you'll find it to be that way. Imagine this. We have a PV, which is the question mark, right? Because we're solving for it. The next thing is we have a payment. In this case, what's the payment? 0, right? 0 coupon. Next is what's the interest rate? So here I'll just put you to maturity, and that is 0.07. And then the F fee in this case, which is the final payment, is $1,000. And we're ready to go. The PV, which is the unknown, I just put it right next to it, equals PV, open parens, the rate, which is 0.07, comma, the number of periods is 5 years. I forgot to put that. And then the payment amount is 0, comma, and then the F fee is 1,000. So the answer is $712. So what that means is you would pay $712 today and then just sit and wait 5 years. And at the end of 5 years, you'd get one big check from the issuer of $1,000. So that's a zero coupon bond. Like I said, very simple. It's a direct application of the PV-FV formula. Next is just an observation that it is possible for a zero coupon bond and a normal bond to have identical yield to maturities, but they're very different, right? As we notice, in one case, you get nothing for the entire life of the bond and one big cash flow, or you get money all along the way and a check, maybe not as big, but a big check at the end of the period. So on appearance, it looks the same, and that's not very good, that we might be deceived with simply looking at a yield to maturity. What we're going to now look at is another way to view a bond, and it is the duration. This new word may strike you as, oh, yet another term, but it's not really a tough concept. What it really means is this the weighted average time for you to get your bond payments. It gives you a sense where the tipping point is in terms of your bond payments. And obviously, in a case of a coupon bond, you're getting some money along the way. So the tipping point is less than the full life of the bond, as opposed to a zero where you get nothing until the end. So the duration of a zero is equal to the life of the bond because you get nothing until that point. So that is the waiting time for any money. Let's look at this example. We have a 3-year bond, $1,000 face, 7% interest rate, with a normal coupon payment of $70 per year, basically 7% of 1,000, and the yield to maturity is 7. What is the duration? We're going to illustrate how to do a duration formula here. What we notice here is that we have 3 years, and then the cash flows for the first 2 years is exactly equal to the interest amount. And then in the 3rd year is this combination of $70 interest plus the full face value. The PV function is a little bit different from what we've done before. We're simply doing the present value of each of the payments. PV of the 70, PV of the second 70, and PV of the final payment. Then we do this part, which is very unusual. We haven't done this before. This is the essence of duration. This is a key step here. All right, so what we do is we take the PV for a year, which is 65.4, and divide it by the total PV. All right, once we've determined these percentages of PV, we simply use that as the weighting of the years. So year 1 times 6.5% is 0.07, which is really 0.065. Then it's 2 times 6.1 and 3 times 87.3. And so what we end up with is this number of 2.81. So the way we would phrase it is that this coupon bond has a duration of 2.81 years. Now notice it's not 3 because we're getting some money which pulls it toward 0 or toward 1, right? And not much, it pulls it to 2.81. If we take a more elaborate example, this one's from the book, it shows one that has a 20-year. This one has a 20-year maturity schedule. So it's the same process. You know, these are the identical payments here. And then this is the PV of the cash flows. And then this is the weighting of the PVs times the years. And then we end up with a duration of 9.95. And again, duration is stated in years. So this 20-year bond has a duration of 9.95, which means we're front-loading quite a bit because we have to wait so long for the face amount to be paid that pulls the duration closer to today. So that's the duration of a longer-term bond. Let's try it out. Well, let's do that comparison between a coupon bond of $1,000, 5 years, 6% annual at a price of $1,000 versus a 0 at 1,000, 5 years, 6%, no payments, and a price of $747. And so we're going to do the two durations. Okay, so let's go back to Excel, go to duration, and we see these side by side. So let's start with a coupon bond. Figure out the cash flows. The cash flow equals the face, 1,000, times the interest rate, the coupon interest rate, 0.06, and it's annual, so that's all it is. And then each year is the same. Last year is a 60 plus the face, so it's plus 60 plus 1,000. The PVs are what we learned before, which is equal to 60 divided by, let's do this correctly, open parens, 1 plus the interest rate of 0.06 raised to the power of 1. And so we'll copy that all the way down. And just to check one of these, let's check the last one. It equals 1.06 raised to the power of 5. So that's good. So now we take the sum, and it's 1,000, which makes sense because we issued this at par, and so the sum should be equal to the face. Now the tricky part, or the duration part, you take the present value of each of these and divide it by the total. We copy that all the way down, and we use that as a factor to weight. 1 year, or year 1, times that factor, and we do the same all the way down. Then we sum it, equals sum, open parens, shade it, enter. The duration is this many years. So that's in years. 4.465 years. Now the cash flow for a 0 is simple because it's 0, 0, 0, 0, and then the full amount, 1,000. So the PVs, this would be 1,000 divided by, open parens, 1 plus the 6, what's it? Yeah, 6%, 0.06 raised to the power of 5. Sum it, which just means that number. And so the PVs are, these are zeros, right? Because there's no money. So that basically means by definition, this is 100%. And so the weighting is that times that, right? So we didn't really have to do all the math. And we would sum that, and that basically is the same number, right? Oops. So this is 5 years. So we have a difference of 4.4 years versus 5 years. So a couple of observations. First, for a zero coupon bond, the duration equals the life of the bond, right? Because there are no other payments, so almost by definition, the duration has to be equal to 5 in this case. However, the duration for the coupon bond, let's make that bigger too, duration is dependent on the cash flows. So there's no simple rule, we just have to do the math. So which one is riskier? And if you think about it, we normally think of risk as anything that reduces the chance of us getting our money. In the case of a coupon bond, there's no guarantees for anything, but every year you get some money. And although you still have to wait till year 5 to get 1060, along the way, at least you're getting $60 a year. You put in the money and you get nothing. So you're sitting year 1, 2, 3, 4, and you're just hoping that the company will be able to pay you the amount that they're required to pay you in year 5. And then year 5 comes and you're crossing your fingers that you get it, because that is 100% of the cash you'll ever get. So when you put it that way, I think it's quite clear that the risk is higher on a zero because you're waiting for longer, in this case, as measured by duration, you're waiting for a duration of 5, as opposed to a coupon bond. At least you get something during the years, and it has a lower duration of 4.46 or 4.47. That's what we do. Now, in industry, in the finance industry, bankers particularly and investment managers look at durations. And what they're trying to do is have a portfolio that has cash flows that meet the needs of their entity. So if you're a pension plan, you want a bond portfolio because it has a fixed return. However, you need to have the bonds maturing so that you can pay off your pensioners. So duration is a very important concept, particularly in investment companies and in pension plans.